Hi everyone, welcome to our webinar, How to Build an LLM Chatbot Powered by Agents. My name is Yukti and I'll be your moderator today. So one of my main jobs here at SingleStore is to organize and drive weekly AI webinars. We organize 2 webinars per week. We demonstrate data and AI use cases and different tools and technologies. I also post about our upcoming webinars every week. So if any of these topics are interesting to you, feel free to connect with me on LinkedIn to stay in loop. Also, I'd like to hear your feedback or any ideas or suggestions on topics that you would like to see in the future sessions. Speaking of future sessions, we've got several new great webinar sessions coming up. So can you please go to the next slide? You're welcome to RSVP to our upcoming webinars. On July 30th, we are presenting how to build real-time AI apps on Iceberg Data, which is tomorrow. On July 31st, we have building fast Gen AI apps on Mongo Data with SingleStore and Kai. And on August 1st, we have how to build an LLM chatbot powered by, sorry, I think this is the title for today. August 1st, we have how to make full stack MongoDB and JSON apps 100x faster. I will put it in the chat. Sorry that you're not able to see it right now. So if any of these topics are interesting to you, please RSVP right now. And I hope to see you all there. Also, you'll notice that we now have an auto RSVP feature to our webinars. Like that's just available on our website. So if any of these webinars are interesting to you, there's now a checkbox to auto register, which will add future upcoming Zooms automatically to your calendar, which you obviously do not really need to join each webinar live, but this is just an option for those who have requested to automatically receive the video recordings or any links, papers, which are useful for the sessions. So feel free to check it out. You can always opt out as well. So back to today's topic, you're welcome to participate in the discussion throughout the session using the Zoom Q&A button, which is present at the bottom of your console. We have an internal mission statement to answer 100% of the audience questions, even if that means following up with folks afterwards via email. This has gotten a little difficult over time because sometimes we have like a lot of questions, which is not exactly possible to be taken live. So, but we're absolutely up to the challenge. Just make sure to ask away. Also just make sure that you have logged into Zoom with your actual name and email address. So moving on, we also love you all to have a dynamic experience during this webinar and try out the technology that we are showing off today. Anyone who tries it, can you go to the next slide, Vanija? Anyone who tries it today will be entered for a chance to win either branded new AirPods Pro or Meta's new Ray-Ban LLM smart glasses. It's absolutely your choice. Simply click the link that's present on your screen, or you can just scan the QR code. It will take you to our trial page. And if you already have an account with us, just log in. And if you don't, rest assured that we have a free tier and it's absolutely free of cost and it takes just 30 seconds to sign up. I will announce the raffle winner before the end of the session. So moving on, I'm very excited to announce our speakers for today. Joining us today is Vinija and Akmal. The database experts, and Akmal is a very regular speaker at our webinars, and Vinija is a database expert and an AI leader at Amazon. So very happy to have you both here. I believe, Akmal, initially the stage is now yours, and then we'll pass it on to Vinija.
Yeah, great. Well, thank you, Yukti, and thank you all for participating today. Yukti, there's a message on the Q&A from Said. He says, no sound. I can hear you perfectly well, and before we started as well, I could hear Vanija as well. So that might be something local to you, Said. So why don't you log out and log back in again? Try that, see if that's assists you. Yes, thank you, Hisham. So you're saying the sound is fine. Okay, sorry about that. Must be some small technical glitch. But there we go. Okay, so I've just got like 2 or 3 minutes before I hand over to Vanija for the main part. So I'll just say a couple of words about SingleStore itself. So company started off in 2011. Both the product and the company used to be called MemSQL, focusing on OLTP, in-memory processing, okay? Hence the name Mem in the MemSQL. Subsequently, a few years back, added support for columnar storage, the ability to do analytics, so these operations, sum, min, max, average, count at scale. And therefore, it didn't make sense to keep the name Mem anymore, MemSQL. So it changed it to SingleStore. and other sort of capabilities. There's multimodal capabilities, which we'll look at on the next slide. But really, the focus is on giving customers and users the ability to handle both types of data. So there now is a single table type that can handle both types of processing, both OLTP and OLAP. The technology, the product itself is MySQL Wire compatible, which is great because you can use existing MySQL tools with it. And it's also MongoDB Wire compatible. Okay, so that's something that was added not so long ago. And you saw at the beginning, just a few moments ago, Yukti mentioned a couple of these webinars in the pipeline coming up covering Mongo compatibility and talking about SingleStore Kai, which is our tool for handling MongoDB compatibility. Just a quick FYI, and I can just sort of raise a bit of awareness. I've got an article at DZone, which is just going to hopefully be published I think it's on Wednesday, where I'm looking at how SingleStore Kai supports the dollar vector search operator from MongoDB. So it's a very short article, but there's an associated GitHub repo as well. So if you're interested in trying that out, that might be worthwhile. Great. Okay, thanks, Venetia. Just quickly, the next slide. So this is a kind of a nice big picture, if you like, 30,000-foot view, just highlight some of the capabilities. So on the left-hand side, you can see fast ingest and CDC. So you've got a variety of technologies that you can connect to. Kafka, we've demonstrated in the past. Apache Spark as well, we've demonstrated in terms of transformations. mlib, for example. If you're working with S3, Hadoop, HDFS, you can consume from these sources at scale. The animation there, you can see it's demonstrating this concept of pipelines, okay? So you can really ingest data from these sources. And that's, by the way, not an exclusive list, okay? They are just some examples. There's lots of other technologies you could work with. Along the bottom there, you can see the AWS, Google Cloud, Microsoft Azure. I'm guessing, Venetia, you're going to use AWS today, obviously, or you're going to run it locally. But on-prem as well, you could do that if you wish. There is, if you create the account, log into the portal, under the settings, you can actually get a license to allow you to enable to install a 4-node version free of charge. So that's the full product. And the only limitation is just the number of nodes. Okay, so you could run that locally. You could run it in the cloud if you want, anywhere you want. You can install it. There's a Docker container available as well. But the quickest and easiest way to really get hands-on is to follow the link that Yukti has posted in the chat. Okay, you can create a free account literally in 30 seconds, and you can be up and running in another 30 seconds, because what they've done is that as soon as you create an account now, automatically you get a free tier enabled for you. There's no need to even create that for you. Okay, it's done automatically. That's wonderful. So you can be up and running very, very quickly. Very quickly then, stored data types. So relational, obviously, that's where the technology came from. It's its background, but we support other capabilities as well. Geospatial, time series, key value. We have a customer actually using it for key value, just something that I knew we had that capability, but I wasn't quite sure whether any customers were using that. And I was pleased to find that that is actually in use. JSON, naturally, and vectors, of course. Vector support has been in the product actually for quite some time, since 2017. A financial customer requested that capability. So it's not something we just added recently because it's popular and everybody else wants to do it, but it's actually been there, used in production deployments for some time. And my boss, Maruka, who's the CEO at SingleStore, recently asked me just to put together a notebook, and it was a kind of an interesting exercise for me, just starting off very simple, kind of couple of tables, orders and customers, and then gradually building up, adding, for example, time series, adding geospatial, adding full text, adding JSON and vectors. And so by the end of the notebook, you can literally cover all of the capabilities. And actually, it's a very small notebook. So we may actually publish that very soon. I think we're preparing that for something else, but we might share that on SingleStore Spaces in the near future. And I think that's pretty much it. So, applications, real-time analytics. And I think Venetia is going to cover a very interesting use case today as well, a very popular one. Simply by the numbers of you that are attending today, it looks like it's going to be a great topic. And so with that, I will bow out and with Yukti, I'll be there helping to answer your questions, okay? And I'll hand that over to Venetia now. Thank you very much.
Thank you. Thank you so much, Yukti and Akmal. Excited to get into this today. So just wanted to start off with a quick agenda, what we'll look into, what we'll talk about today. So we're going to start off with looking at LLM chatbots as well as AI agents. We're going to kind of do a deep dive into the architecture of how agents work. And then we're also going to look at use cases. How can you apply them in the real world? As well as then we're going to also look at a quick demo that I have of using an LLM chatbot with an AI agent for a customer service use case. You'll have the code and all of these slides with all of the links within the slides available to you after this webinar. So you'll be able to go in and, tinker around with the code yourself and then look at all of the different publications and papers that we talked about through this as well. So yeah, let's get started. So how to build a chatbot with AI agents. So wanted to quickly start off with what are AI agents? It's been going around, the term's been going around for quite some time. They've been kind of revolutionizing the entire landscape of AI currently. So what are they really? So I've pulled out a few definitions that are able to describe them in the best way I feel is possible. So AI agents are autonomous systems designed to perform tasks by making decisions based on their environments and their inputs. They can be kind of described as systems that can use LLM to reason, use LLM almost as the brain to reason through the problem, and then create a plan to solve the problem and execute the plan with the set of tools that they have been given. So example, like I mentioned, what we'll be covering is a customer service center that's looking to answer a few customer queries. And the agent will kind of ask kind of questions to be able to clarify the customer's request here. Then they can look up documentation, respond with a solution, whatever access to tools they have. So a quick workflow here is, say a user comes in and says, hey agent, what is the maximum number of official matches for all of these plays that have been in this season? The agent will take that query, first go through its thought process through its LLM, decide the action, do an observation, make sure the observation aligns, proceed with other actions such as looking up on the web. Once it's able to get a confidence level on the answer, then it can respond back to the user. Now, this is just one use case where it's kind of doing that sort of text to text. There's also multimodal agents, and we'll look at those as well. And just another quick note, if you would like to read more about agents, I have a blog, venetia.ai, where I have an article on AI agents. There's more code and more stuff covered there that I won't be covering today, so feel free to check that out as well. So also wanted to start off with a quick kind of explanation on how are AI agents really different from virtual assistants like ChatGPT. So let's start with what virtual assistants are really good at and what they're really capable of. So they're really great at doing more user-focused interactions, right? So virtual assistants are kind of primarily designed to interact with users through the natural language text flowing back and forth, and it's focusing more on the user's experience. Virtual assistants are also task specific. You can use them to help set reminders, manage emails. You can think of, say, Alexa, where you can help it set reminders for yourself, any various tasks, add a repetitive order on your grocery list. They have conversational abilities, of course. That's what they're mostly leveraged for here, to engage in conversation, understand the user's request, take responses or actions based on the user input. And they can also integrate seamlessly with your ecosystem. You can have, say, smart lights be turned on and off with your virtual assistant here. A lot of different here varied tasks that virtual assistants are commonly known to do. So how are AI agents different from this? AI agents here mostly focus on autonomy. So AI agents operate independently and they make decisions without human intervention, kind of based on their learned experience. So you'll see later as well how an AI agent is actually able to do both perception, use thought, and then use all of the tools that they have, whether it be web browsing, whether it be looking through a RAG pipeline. They're able to understand the problem and understand their tool set that they have, and then leverage that to best be able to answer the question for the customer here. They are more reactive and proactive. So they can react to the environment change and take proactive steps to be able to achieve those goals. And they are more goal-oriented. So they're primarily focused on achieving specific goals, solving complex problems, and they can perform tasks like booking your appointments. So say for a virtual assistant, perhaps you can ask, when are the flights leaving to a specific destination you're looking for, or say, what are the openings for a restaurant? But an AI agent can take that task one step further and actually book those appointments for you. So you can just tell the AI agent, hey, I'm looking to have dinner at this restaurant on this date. It will go ahead, find an open slot for you, and add your booking there for you. So all you have to do is just have that conversation. Whereas with a virtual assistant, you're just kind of getting help with the details, but in the end, you are the one performing the task, whether it's booking your flight, booking your appointments, booking your reservations. It's you on the other end doing all of that work. And AI agents also have adaptability. So many AI agents have the capacity to learn from the outcomes that they kind of saw and modify their actions accordingly. So they have this feedback loop, which is really helpful in helping them learn and understand and become even better. So a few examples I thought of here where you would leverage agents versus virtual assistants. So for an agent, you can kind of ask, can you explain the difference between quantum and classical computing? You know, you can really get into the nitty-gritty details here, and you can really expect a response. And a response, say from the web or say from a specific book if you've given it access. And a virtual assistant, you can ask more sort of actionable questions like set a timer for 5 minutes or what's the weather today? Perhaps it will be able to answer at least the definition of quantum classic computing, but it will do a web lookup and maybe it won't really understand the fine-grained detail you're really after there. And then the other example here is plan a week-long trip to Thailand, focusing on historical sites, cultural experience, and with your budget there. And the agent will actually go ahead and schedule out a whole plan for you. And once you've kind of okayed it and approved it, it will actually book your whole itinerary for you within your budget, within all of the specifications that you've asked it to do. Whereas for a virtual assistant, what you can do is once maybe you're in the location or as you're researching the location, you can ask it to find nearest coffee shops or, you know, find the nearest historical or cultural experience from where you're staying. But again, most of the work is on you, whereas the agent is able to run independently, given the constraints you've given it and given the tools that you've given it, and is able to perform the task end to end for you. So let's look at the kind of overall architecture here that agents use. And this is taken from this paper, The Rise and Potential of Large Language Model-Based Agents, and it's a survey. It contains a lot of rich information about agents, and we'll be looking at different pieces from this paper, but let's start off with the overall architecture that they've proposed on how to use agents. So from the paper, they've mentioned that LLM-based agents contain these three main components. The brain here being the LLM, the central piece, the perception here, and then the action. all the way here. So the brain here is serving as kind of the controller module that's kind of undertaking the basic tasks like memorizing, thinking, decision making. All of the central tasks here are done by the brain. Then we have the perception module, and that's looking to perceive and process multimodal information or just one modality, if that's your use case, information from the external environment that it's receiving. So this is the external environment, and it's just looking to do a perception on its external environment here. And lastly, what we'll have is the action module, which carries out the actual execution using all of the tools, and then it looks to influence its environment. So the brain is kind of the central piece here that's looking to, have the storage and also do the decision making here. Then it'll go to sort of the perception here. The perception will look at the environment and look at all the multimodal or single modal inputs that you've given it. And then finally, the action will look at the text, the tooling, all of the different items you've kind of given it to work with, and then look to influence the environment. So the use case that they have in this image, the entire workflow is, so a human asks whether it will rain. So the human's coming in, it's looking at the sky, will it rain tomorrow? And if so, give the umbrella to me. This is the start of the pipeline. Once the user has asked this, it will go into the perception module. The perception module will convert the instructions into an understandable representation for the LLM. Again, the LLM here is the brain. Once it's able to translate the human's query into something the LLM can understand, the brain module will take over and it will begin to reason according to the current weather, according to the current weather reports on the internet, all of the different information that it needs to do to be able to answer this question. And then finally, it will talk to the action module and respond to the user by handing them an umbrella. It will go through this loop and be kind of repeating and iterating through this loop and getting feedback and updating its kind of pipeline. And by giving it an umbrella, of course, in this scenario, if your agent is software, it can't, really give an umbrella, but say this agent is kind of a robot here. So while it's doing this perception, brain, and action module, and it understands that the user actually needs an umbrella, the robot can actually physically hand the umbrella to the user. There's also a slide where we'll look at how agents can live in a simulated world with people, also taken from this paper, and we'll see that more in action later. But this is the kind of architecture and the different components that agents generally have. It'll have kind of the external environment here, the perception here, then the brain module being the LLM here, kind of being the controller, as you can see. It's kind of the middleware. It's talking between the different modules, and then it's looking to kind of get that response or action or whatever's in its tool set to be able to perform the action for the user. Now, this is the simulated agent society that I was talking about, and this is again from the same paper that we were looking at earlier. So this is their proposal of how agents can actually work within our society. And you can kind of see that it's divided into two main parts, the agent part and the environment part here. So, and it's also divided at an individual level for each agent, at a level where the agents are working in groups synchronously together, and then where they're able to kind of synchronously take the actions that are needed for our environment here, whether it's our virtual environment, whether it's our physical environment, or whether it's, also connecting with humans and resources. So even at an individual level here, the agents can kind of internalize different behaviors like planning, reasoning, reflection, they can also actually start to display their own intrinsic personality, involving cognition, involving emotion, involving different characters. So they can almost, work as an individual themselves by internalizing the different behaviors. Now you take this individual agents and you form them into a group with other agents. They can, exhibit other group behaviors like cooperation, working together, understanding how to do that the best way possible to be able to live in a society. And then the environment that you have, whether it be a virtual environment or whether it actually be a physical environment, will also contain human actors here, and all of the available resources you have. So for a single agent, or other agents are also considered part of this environment now, and agents have the ability to interact with the environment through the perception and the action modules that we saw earlier. So what they're coming in is now the environment, and the question they're being asked is done via this virtual physical environment. So these are the robots, that can kind of look and hand you the umbrella from our prior scenario. And once the question kind of comes in from this virtual physical environment, the agent will kind of look back into its perception module, look back into its own reasoning skills, all of the tool sets that it has, and then perform the actions that it needs. In this society scenario, the benefit that this has over the single agent scenario that we saw earlier is the collaboration that these different agents have. They can kind of even leverage each other as a tool, as an external set to be able to best answer the question. Maybe there's one agent who's the best at understanding weather patterns, and maybe there's another one that's better at historical data, just because of the environment that they have been working in. In that case, perhaps it's more beneficial for the current agent to be able to kind of converse with those agents and be able to leverage all of the information they need to be able to then perform the action back in the virtual or physical environment here. Now let's look kind of even deeper into the architecture of the agents. So this is taken from NVIDIA's blog. I definitely recommend checking that out as well. They've been able to kind of divide up the agent architecture into these simple 4 components here. So you'll get the user request coming in. It'll go into the agent core. The agent core, again, being the LLM here, being the kind of controller, if you think of classical software engineering, the controller talking to all of the other modules that you have here, talking to the memory module, talking to the tools that it has, talking to the planning module. And we'll dive deeper into each of these different modules that you'll need to have in order to be able to create your agentic architecture. So let's start with the agent core. This is definitely the key piece here. Whether you have the other modules or not is up to your use case, but you can't really have an agentic architecture without the agent core. So agent core is the central command and the control center for the AI agents. It integrates with various functionalities, manages tasks, directs the information flow coming through the users, coming through all of the modules back and forth, and ensures that coherent operation across all of these different modules is happening and is being attained. It is kind of that decision-making engine. It is the core of all of these agent. It includes algorithms responsible for the decision-making. So these algorithms can kind of help analyze the data from the memory and the inputs from external sources to be able to make that informed decision to be able to help the user in their questions here. So the agent here is kind of working as the central decision piece, and it's deciding based on the user query, do we want to look at the memory? Do we want to look at the past memory, something we've already answered, something we've done before, and just leverage it from our memory and answer? do we want to this is a planning scenario where we're looking at more of a planning module here, or do we need to actually leverage all of the tools in our tool set to be able to answer this question? And the tools can be whether a RAG use case or external website lookup, any tools that are needed for the system that maybe don't exist in our memory module currently. So now the memory module that we saw earlier, this also, plays a critical role in the AI agent architecture. And it's you can think of it in two different forms here, two different types: a short-term memory and then a long-term memory. So a short-term memory is actions and thoughts that the agent goes through to attempt to answer a single question from a user. So like the agent's train of thought. And a long-term memory is a a longer set of scenarios that the actions and thoughts about the events are happening between the users and the agents. So it's you can think of it like a logbook of conversation history stretching across weeks or months. So this is very similar to, say, a ChatGPT session where maybe you're starting off asking a question, a mathematical question, and then you just keep asking other details about that question, and you're going on and on. ChatGPT needs to understand and keep a sense of that memory of what you had asked initially within that session to be able to best answer your next question. At every point, you can't always be explaining that, hey, this is the same math question I was asking earlier. Can you explain this different piece on it? Hey, this is the same question I asked about. That breaks conversation. So it needs to keep track. It needs to keep that long-term memory. Agent use case here is keeping an even longer memory where it's looking to keep weeks worth or even months worth of that information going, so that if you ask it, a question again, it's able to look within its memory, say, hey, you asked something about this earlier. I remember this context. So now with that context, I can give you an even better answer here. And memory requires more than semantic-based similarity at retrieval. It's typically a composite score made up of semantic, importance, recency, and other application-specific metrics here needed for the retrieval purpose. So what it's saying here is you'll be retrieving the relevant information from within the memory module through a similarity metric, but the similarity metric goes beyond just semantic similarity. It needs to include importance, recency, and other specific metrics here. Now we'll also look at the tools module. So the tools here are specialized functions or external services that the agents can employ to execute specific tasks. They can, have a wide range of different sets of tools that can be very diverse. They can be characterized by direct applicability to the tasks at hand. In fact, your tools can also just be other agents, like we saw in the society simulation use case. So in order to have executable workflows, you can often script the actions and processes defined at the higher level language that directs the agents on how to perform these specific tasks, such as data scraping, sending emails, executing transactions. You can also have automation hooks, and these tools are equipped with the interface for the automation, letting the agent trigger them based on certain condition without manual intervention. So you can think of it like, say, you come home at 5 p.m. every day and you need your living room lights on when you come, and you need your heating or your cooling setting done. These are your automation hooks. This is something that your agent can get done for you and monitor for you. And this is unlike, say, you can do that currently too. These agents are more, because of the tools they have, they can make a better informed decision. Say you normally have heating set, but they're able to look at the weather outside and they understand that, oh, it's really hot outside. Perhaps today you don't need heating, perhaps you'll need cooling. They're able to executively make that decision and make that change for you without you having to think about it twice. You can also think of tools such as APIs. So you can have external APIs, third-party services that the agents can interact with. Again, this can be weather, finance data, social media service, any other data sets that you need to kind of be able to chat with. So it will basically leverage this API to send and receive data to be able to extend its capabilities beyond what it has within its internal resources. It can also leverage its internal APIs that perhaps you can develop for your agent to be able to communicate securely and efficiently with, say, other agents or with any other kind of task specifically within your system that it's living in. You can also kind of have middleware act as a bridge between the agent's core logic and the tools it's using. And the middleware here will kind of handle the data formatting, error handling, any security checks to ensure that the tools are interacting, they're seamless, they're safe. You know, a lot of these checks and balances can be done with adding in middleware into this architecture. So the architecture we saw is a very high level overview. When you start zooming in a little bit, you'll need to make sure you have authentication, you have, especially as you're looking to transmit data back and forth between the different modules, between the different agents, you need to make sure all of your checks and balances are in place there. Now, let's get into a little bit more of an interesting scenario here. This is the multi-agent system now. This is again taken from the same paper that we saw earlier. And these are the two scenarios that they have proposed where multi-agent systems will work best. So what they say here is the LLM-based agents, they kind of work very well at text understanding, but often work in isolation, kind of limiting the multi-turn feedback and the collaboration that happens. The LLM-based multi-agent system emphasize the diverse agents interaction, collective decision-making, improving the task handling through specialization and through cooperation. And they're saying there's two different types of interactions that can happen with multi-agent systems here. So you can have cooperative engagement and you can have kind of adversarial interactions here. Cooperative engagements being agents are able to collaborate, share information with each other. You can have it, disordered or in an ordered format here, similar to the way how humans work and how humans communicate. What it's basically saying is that if you have an agent kind of working in isolation, the feedback loop there, the ability to be able to enhance its kind of task performing skills for it to be able to learn and grow can be limited since the multi-turn feedback and the collaboration there is limited. It's only chatting with the user, it's only providing feedback. It's not really learning from other agents in the ecosystem. Now, if you bring on more agents, they're able to do somewhat of transfer learning and also able to learn from each other in these two different methods, which is cooperative engagement and adversarial interaction. Cooperative engagement, you can have two different forms here. Disordered, somewhat like, say, in a meeting room where folks kind of start chatting and everyone's kind of giving their point of view, not in a very kind of organized manner where there's one person who talks then another. Maybe like a party situation or a scenario where different folks are chatting with each other and you're just kind of overhearing and they're just able to learn from each other that way. Or in a very organized fashion here where you have an agent that works as a manager, they start off the conversation, then they're kind of looking to talk to each other individual agent. One agent's just the designer and that's its task. It's very good at designing front-end applications. The other's an engineer and it's really great at doing back-end and that's its task. And the last is a tester. So running as a team would in a sort of a tech company here where the manager is able to chat with the designer, who's able to chat with the engineer, is able to chat with the tester, and have a very organized workflow here to be able to get the tasks done. Which situation works best for you would really depend on your use case here, whether organized or a disordered use case here. Adversarial interaction is the other form of a multi-agent system that the paper proposed. And what this involves is a dynamic strategy, kind of having adjustments, incorporating game theory concepts, kind of enhancing that debate and decision-making skills. Having those like long debates, really challenging its thought process. So you can see here, the designer is asking, I think the user needs a simplified interface. The engineer agent comes in and says, that's a great idea, but technical limitations may affect the performance. The designer says, true, but simplification does enhance the user experience. The engineer agent will say, yeah, but performance issues also impact the overall satisfaction. I will try my best to balance both aspects. So this is kind of, you know, almost a real world scenario here where, because they're actually able to have this long debate, they're able to bring out the best product here at the end. Say instead, if you had just asked just an LLM, not even an agent, to be able to make a simplified interface for you, they would have come up with an initial draft here. Then you would have to go in and say, I need something with these technical limitations. I need something that simplifies user experience. You would keep going back and forth, back and forth. In this scenario, the agents are able to do that for you, to be able to understand the decision and the criteria for you based on the environment and the settings that you have given them. They're able to help you in this decision-making aspect to be able to get the best product out there for you without you having to do that sort of long conversation and debate there. There's also multimodal agents, and also wanted to touch on this and how this would work and help in the environment. This is a different paper here. This is called Large Multimodal Agents, LMAs, and the link is provided right in the slide, which you'll have access to right after the webinar. Basically, what they propose is that these LMAs understand and respond to various data types, including text, images, videos. As you can see, this is their environment. Their environment includes text, images, videos, music, what have you. They have the perception module that we saw earlier, and the perception module in LMAs is looking to analyze the data from these different sources, such as, you know, you can have different situations where it's looking to identify objects and images, understand the spoken language, understand the songs that are coming in, take in the text and see how it correlates with all of the different modalities that are coming in. Once it's able to do this perception, then it'll go into the planning module. Well, they'll look to reason and plan and formulate strategies for the task, like scheduling based on the user preferences. Once the perception and the action takes place, then you'll have the kind of action module here. And LMAs here in the action module are looking to execute the plan using interactions or tools, like booking an appointment through an API, playing a certain song, perhaps generating a slide based on the music, based on the images, based on the text you provided, making a presentation, making an educational video, whatever the action output you have, that's what the action module here will perform. And they will also have a memory module here that we saw earlier, which is looking to store and recall the information to kind of enhance that decision making and also personalize the experience, remembering the user's preferences for the future interactions there. You'll have the kind of the GUI automation happening here. So you can have a GUI, you can maybe just speaking to a robot directly. It can work for game development as well. That's a great situation where you may need multimodality, you may need music, sound, images. Use all of these modules to be able to kind of help plan and create those action outputs there. The paper proposed these kind of 4 sets of different architectures for large multimodal agents. The type 1 is a closed-sourced LLM as a planner without the long-term memory. And they'll maybe mainly use the prompting techniques to kind of guide the closed source LLM here. The type 2 is the fine-tuned LLM as a planner. So the LLM, the brain that's coming in is actually fine-tuned based on the task. And this is again without the long-term memory. And it's kind of used more for action-related data to find the existing kind of open source large language model to enable and achieve the decision-making that's needed for the user. C here is the type 3 planners with the indirect long-term memory. And D is the 4 planners with the native long-term memory module here. So these are the 4 different types of architectures they've proposed based on the different components that we've seen in the agentic architecture landscape already. And they've just suggested, there's different things, nuances you can do. You can fine-tune the LLM, the brain that's looking to communicate here. You can work with long-term memory, maybe not have memory at all, maybe use short-term memory, decide which actions to have, decide how your perception is going to work, which modality it's going to take from its environment, whether it's going to require all of them, whether it's going to be able to take them, how the actions are going to look depending on which modality is provided. All of those different scenarios and situations all together. This is another use case I would definitely recommend going through their website here. So what they've done is they've actually implemented an agent use case here. They've called it Baby AGI since it's a mini version of AGI running here. And this is kind of a task performance agentic framework. Basically, what happens here is the user comes in, provides a task and an objective. It goes into the task queue. They complete the task, execute the task. It goes to GPT. It goes to the memory module. The memory module can go back to the execution agent, which is also a different version of GPT here, gives context, can send the task back, can give more context, and then you can provide the answer back to the user. You can have it prioritize the task here. You can have it fill in the task queue. Yeah, that's the general overview. Their website is linked below, and they also have the code available there. These are a few other notable LLM-based agents that currently exist. These are the different publications from those agents. And these span, different fields as well. There's the ChemCrow, which is an LLM chemistry agent that's utilizing, chemistry-related databases to autonomously plan and execute and synthesize a lot of the insect repellent use cases here. So, I definitely suggest you go and check that out. This is for chemistry. This one is looking to assist researchers on tasks such as generating abstracts, scripting, extracting keywords. All of these all linked here below. Definitely go ahead and take a look at that. Also wanted to say a quick word on SingleStore's free share tier. The code we'll see today is actually developed on the SingleStore notebooks here. Would highly recommend signing up for the free trial and leveraging that yourself, leveraging the code that you're going to get today, run it on a SingleStore notebook, and see what different situations you can have it. See if you can kind of implement the RAG pipeline from the previous webinars here and see how it works for your use case. So now quickly want to talk about the demo as well, what we're going to see here today. Kind of created a customer service agent. This is the output from the agent. My agent is software-based. We don't have robots here today. But basically we have a customer service agent, and I asked it a few scenarios about the product. I said I was having issues. I asked about the warranty, gift wrapping, whatever, I came up with, and it was able to go through its perception, action, all of its plans, and to be able to answer me in the best way possible here. Also quickly wanted to mention that the other use cases here that you could use is, RAG-based use cases from our prior webinars. So you could definitely include that within this agentic pipeline to be able to kind of fetch documents and material from your own vector database stored within SingleStore here. So now, without further ado, let's get into the code base here. So this is the SingleStore environment here. And this is what our code base is going to be. I'm going to go through this pretty quickly, so we have a few minutes left for questions. I've already run this. We don't have time to run it live. It takes a few minutes. Would definitely recommend that you try it out at home. So the way it starts is you'll install all of the different packages you need to be able to run this. Once the installation is done, then this is the core logic here. This is the customer support agent. I'm using this open source model here. The reason I use GPT Neo is because it's a causal language model. I just assumed that, with the causality here, it would be able to do the kind of back and forth interactions better. And I did see that in the performance. There's these others you can use. You can also just, use the API call from OpenAI. Whatever, that's up to you there. I also used it to be able to run within the kernel and the memory storage here available. So that's the model I used. All of this stuff here is initializing the model, the tokenizer, all of the, the precursor steps here. Then we have the perceive, the decide, and the action modules, as we saw earlier. And this is a very, a smaller use case scenario here. You can definitely have it be more elaborate. You can have it work with multimodality. So the perception here is looking to basically process the user's input and update the conversation history. And it's looking to just return the processed user input converted to lowercase here. The decision module here is looking to generate a response based on the user's input and conversation history. So its output is going to be the generated responses from the language model. And then the action is looking to finalize the response, append it to the conversation history, and return it. And this is for the context, the kind of short-term memory module hack here. So it's able to kind of keep context within the session that we're running it. And then run here will actually look to first start and call the perceived module based on our user input, then call the decision module, and then the action module here. So this is the use case that I ran with. When you run this, you'll have a little chatbot appear here, which will be a box, and it'll say you, and have it ask you a question. So the assistant started off with, "Hello, how can I assist you today?" And I said, "I'm having an issue with my product." It said, it was able to say, "I'm sorry to hear that you're having issues. Could you please describe the problem?" And then I just wanted to know the return policy. It was able to generate a return policy here. Can you tell me about the warranty? It was able to tell me the warranty. Do you offer gift wrapping? Yes. Can I change my order after placing it? If your order hasn't been shipped, you can modify it. So that was the quick back and forth conversation I was able to have with the agent. Definitely would love to see your use cases there. And with that, Yukti, let's take a few questions here.
All right, thank you so much for the demo. We have a lot of questions for you, actually, as you can see. So, we have one question from, just give me a second. From Webhub, I think I don't know, like if you can decide with Akmal if you like who can take that question. So they say that I don't want to use Pinecone for my use case. Are there any other vector databases similar to Pinecone which stores the vectors locally in the disk? Does SingleStore DB provide a way to do this task?
Yeah, definitely reach to Akmal for this one.
Yes, of course. So if you want to use SingleStore just as a vector database, then you can do that. But you'd really be missing out on all of its other features and capabilities. Interestingly, Yukti, I don't know if you want to post the link to the Dummies book that we have. There's a chapter in there that I wrote, how to get data from, say, two sources, say document database such as MongoDB and, excuse me, a vector database such as Pinecone, and then you can put the data all into SingleStore, and it can handle both types of processing. So absolutely, I mean, there are lots of choices in terms of pure vector database products out there on the market. I mean, you're spoiled for choice today. But as I mentioned right at the beginning of this webinar, SingleStore has had vector support since 2017, much improved earlier this year. Lots of cool stuff in the pipeline as well. And we've published, I mean, numerous articles demonstrating how to get vectors in, kind of processing. And again, I'll just mention I've got an article coming up on dzone in a couple of days showing compatibility with MongoDB, for example, and its vector search operator. So, yep. Short answer, yes. Sorry for the long answer there.
I do believe they have on-prem services. So I was interacting with our sales team. So there are actually some customers that are doing the thing that he mentioned. So I
Yeah, and
hope
so keep in
you have
mind, yeah, sorry to
if
interrupt
you
you.
have,
Yeah,
sorry,
yeah.
sorry.
So yes, the on-prem the product supports vectors out of the box. There's nothing different from that if you want to use vector support. So the vector type, which is the new thing, plus the ANN indexing and all of those capabilities, that comes as part of the on-prem solution as well.
All right. So is there
Yeah,
any
sorry.
question you want to take up, Vanija?
I don't think I see the question chat here.
Oh, okay.
Stop
Okay, I
sharing.
can pick one out for you. So I see some participants raising hands. We actually don't work with the system like that. If you have any questions, feel free to add them in using the Q&A button. So we can take up your question, and apologies in advance. I don't think so. We will be able to take up all the questions. So we will be following up with everyone with the follow-up questions, or like you can always reach out to us. So we actually have a lot of questions. Very difficult to choose, actually.
I know. I can answer this one. Amit said, what do you mean by environment? Could you please give some examples? So environment is very task specific. If you have robots, you can actually think of the physical environment. You could think of society. I don't think, that application is actually out there yet. So in that sense, in our example here where we wanted the robot to hand an umbrella to the user, that's the physical environment. The environment where we're just looking to chat and answer the question, then that's just the software, that's the environment. It's basically the question answering space.
Right. Akmal, I see your hand raised.
Yeah, Yukti, I was this might help summarize a lot of the questions. Lots of people asking for links to the papers, Venetia, the references, the research stuff that you pointed to, as well as your presentation slides. And I guess and I apologize, I wasn't watching you. I was trying to answer the questions, so I wasn't seeing everything that you were doing. But do you have a GitHub repo somewhere where the code, for example, or examples are there?
They're all available within the slides already. I've added the links.
Okay, that's brilliant. And then so Yukti, if you're going to share that anyway, that would be great. I think that will help answer lots and lots of people's questions there.
Yeah, we'll make sure to include that in the follow-up emails. I'll just go through the slides and then I'll make sure you guys have it.
Yeah.
So we have a question from Mohammed Abir. He says, you have already used the pre-trained model. How can we fine-tune the same model for their own use case?
Yeah, absolutely. So I think we have a few webinars in the past that uses LoRa, parameter efficient fine-tuning methods, to be able to fine-tune your model. It's the same process to be able to fine-tune it. And you can look at the past webinars. We've already done that.
Okay, awesome. So we have one more question from Sun Chao. They say that in the example interaction, you can also create such interactions between user and chat GPT using perhaps RAG. What is the advantage of implementing and using the agent model?
Yeah, absolutely. So RAG model, you have the limitation, it's a database, right? The database that's being able to retrieve. You have the limitation of keeping the database updated. Say we have a presidential election today, and there's a new president today versus what's saved in our database, which was from yesterday. The benefit here is that it's able to look up that information and see, oh, there was a president change today, and to be able to respond back to you with the correct information. You can, of course, if your data is not changing as quickly, you can, of course, just use the RAG pipeline here.
All right. So we have one more question from Anurodha. They say that are there any tests that could be performed to check the accuracy or rate of confidence of the outputs?
Definitely. There's a lot of ways to actually evaluate these agents. You know what? I can share that link with you, Yukti. A lot of different benchmarks and metrics that are actually used currently to evaluate just that.
All right. So I think we are almost at the top of the hour. I'm very sorry if we are not able to take up all the questions live. Thank you so much, everyone, for all of your questions. And we will follow up with everyone via email to answer everyone's questions. Or if you have any questions or concerns, you can always reach out to us at team@singlestore.com. I am typing it out for everyone in the chat. So feel free to reach out to us if there's anything that's very unanswered and it's urgent. So we're always available. So thank you so much for joining. Everyone's time and energy really matters to all of us. Everyone who has joined here, like through different time zones. So I think we can wrap up and I can announce the raffle winner for today. So just I have few quick notes before announcing today's raffle winner. Can you please go to the slide that had the
Yes.
webinar? Thank you. So just just a small reminder before announcing today's raffle winner. We have amazing webinars coming up. Tomorrow we are presenting how to build real-time AI apps on Iceberg data, and on July 31st we have building fast Gen AI apps on Mongo data with SingleStore, and on August 1st we have how to make full stack MongoDB and JSON apps 100x faster. So I'm aware that the link in the slide is not exactly very accurate, so refer to the link for the August 1st webinar in the chat. And moving forward, I can announce the raffle winner now that uh, has been picked out. And so today's raffle winner goes to Conthia Van Aswigen, who is a director at Salesforce. Congrats and thanks for joining, ma'am. If that is not you, do not give up. We are going to announce one more AirPods winner and Meta's Ray-Ban winner by the end of the day. For anyone who has tried out today's demo, please sign up at the link that is present on your screen. And I've also mentioned that in the chat. I see that it's not on the screen. It's there in the chat. So feel free to sign up and be eligible and be entered to win, because we will be notifying the winner via email by the end of the day. And I want to thank everyone for joining. Thanks, Vinija, for the presentation and demo. We really value it. And thanks everyone for joining. Have a great rest of the day. Take care, everyone. Bye-bye.